Okay, here we'll be talking about histogram. So the first way of presentation of data or organization of data is using the frequency table. Now, after we have the frequency table, we organize the data. We are going to present the data, and the way we are going to present the data here is called using the histogram. How we can present the data using histogram. We are going to look at the definition of histogram, and we are also going to learn how to construct histogram. First, the definition. Histogram is a graph that displays the data using vertical bars of various height to represent the frequency of the distribution. So for each frequency or each class, we draw the vertical bars, and those vertical bars represent the data or class at a point, and the height of the bar is proportional to the frequency. If the frequency is more, the height is taller. If the frequency is less, the height will be shorter. Few more concept or the idea on frequency distribution that go along with the histogram is this. A histogram is a plot that lets you discover and show the underlying frequency distribution shape of a continuous data. So this one is normally for the continuous data, but the key thing here is the histogram will give you the shape of the distribution. Okay, when I say shape, is it uniform? That is pretty much same frequency throughout, or skewed to the left, or skewed to the right, or normal. We are going to talk about this in a minute, but when I say shape, that is the meaning of that. A histogram is a quick way to get information about the sample distribution without detailed statistical graphing or analysis. Just by looking at the histogram, we can tell a lot about the sampling distribution. And we'll deal with the sampling distribution later on in chapter 8 or 9. But here you can see in the first picture here, we have the histogram, and frequency of almost all the individual bars or height of almost every bar is the same, okay, almost equal. So if the distribution is like this, if the frequency distribution has almost equal frequency value, then we call this uniform distribution.
Right.
Now look at the second one. In the second one, here is the tallest bar. So from the tallest bar, if you try to draw the curve along the top of the other bars, you'll get that. And on the other side, if you go the same way like that, all the way up to x-axis, this is what you'll get. So this is the shape of the distribution. And you can see that this distribution has longer tail to the left. You can see it has a longer tail or extended more towards the left. That means this data has more smaller values. So this type of data in which the frequency distribution has longer tail to the left, it is called the left skewed. Sometimes the left skewed is also called negatively skewed. Let me write that. Negatively skewed, because it is more extended towards the negative numbers. Negative numbers are towards the left. Now, if you go to the next graph here, the tallest bar is here. So we are going to start from there, draw the frequency curve along the top and come all the way down to x-axis like that, and do the same thing on the other side. If you do that, you'll see that you have a longer tail. Okay, you have longer tail towards the right. So this type of distribution has more larger numbers in the data. Okay, more larger numbers in the data set. That's why it is called the right skewed. The long tail is towards the right, or positive numbers. So this is called right skewed or positively skewed. Let me write that, positively skewed. And if you look at the last one here, the tallest bar is here. And if you draw the frequency curve from the top of that, it will look like that. You have pretty much the same shape or symmetrical curve about that point. You have equally extended frequency curve on the left and on the right. So this type of distribution is called the normal distribution, sometimes also called the bell-shaped distribution or symmetrical distribution. So it is also called the symmetrical distribution. Do you have any question on shape of the distribution? You can just say yes or no.
No.
No question on that. Okay. Now we are going to go to the construction of histogram. So here is the example. Let's see, what is this question asking us? Construct a histogram to represent the data shown below. Here is the data in the table. It says temperature in July and number of days. And you can see that this is the grouped frequency table because you have the classes over there. And using the construction of histogram, after you construct the histogram, state the shape of the distribution. So when I say shape, whether it is skewed to the left, right, is it normal or is it uniform? So what we do is, in order to construct the histogram, along the x-axis, always remember, along the x-axis, you write these classes, 50 to 55, 60 to 65. You write these classes or label these classes along the x-axis. So you can see here, 50 to 55, that's the first class. 60 to 65, second class. 65 to 70, 70 to 75, 75 to 80, 80 to 85, 85 to 90, 90 to 95, 95 to 100. You label the class along the x-axis. Then along the y-axis, you label the frequency. Here you can see your frequencies are 1, 1, 4, 5, 10, 4. So we have to go up to a maximum of 10 or little above that. So along the y-axis, okay, you put the frequencies, which is the number of days. So what I'm doing here is I'm labeling by 2, 0, which is right here at the bottom, then 2, 4, 6, 8, 10, 12. Then what you have to do is you have to make the bar at each class. For the first class, you can see the frequency is 1. So you draw a bar of height 1 there. So that is your first bar of height 1. Then next class, 60 to 65, the height is again 1. So 60 to 65, height is again 1. Then 65 to 70, height 4. So draw the bar of height 4 like that. And then 70 to 75, height 5. So 70 to 75, the height is 5. You can see there the height is 5, which is in between 4 and 6. Okay, so that is the bar. 70 to 75, you just continue like that now. 70 to 75, the height is, you can see 70 to 75, we just did that. Then after that, we have 75 to 80, which is 10. Okay, this is 10. Then 80 to 85 is 4. We draw that, 80 to 85. Then 85 to 90, draw that bar. And you can see that the bars are connected to each other. So in histogram, remember that the bars are joined to each other. Okay, they are connected to each other. So this is the histogram. Now, after you draw the histogram, you can see you are asked to state the shape of the distribution. To analyze the shape of the distribution, you can draw the curve along the top of these bars like that, so that you can clearly see what type of shape is there. Do the same thing on the other side like that. What do you think about the shape of this distribution? Is it skewed to the left, skewed to the right, normal or uniform? What do you think?
Normal.
Normal.
It's pretty normal, right? So this is normal distribution. Normal distribution. So we can use histogram to visualize the shape of the distribution. Just by looking at the histogram, we can easily tell the direction of skewness or it is normal. When I say direction of skewness, whether it is skewed to the left or skewed to the right. Any question on this one? First example?
Yeah, really quick.
Oh, yes.
So whenever it says construct a histogram and then it already has one constructed.
No, 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 no. You know, I had this constructed, but it will not be there for you. Okay. You have to draw the x-axis, you have to draw the y-axis, and then you have to draw the class, you have to label the frequency, and you have to draw the bars. Okay.
Okay.
Yeah. Other questions, if any?
Yes, sir. This is Barbara speaking. I had a question about the, I noticed that in the classes that the temperatures overlap. For example, 55 to 60 and then 60 to 65. If the temperature is 60 degrees, how do you know which category to put it in?
Exactly. So normally what you do is this is already a continuous, class that is given to you. For example, if it was not continuous, this is how it works. Let me write something here and show it to you. For example, in real world, what happened is if you think of the classes that we have constructed, the frequency, group frequency table that we have constructed earlier with the age of president and the time at the time of their death. So if you try to recall that, there was a gap, like it was like this: 55 to, say, for example, 60. Then if you remember, we started with a number like 61 up to 65, then 66 up to, let's say, 70, or things like this, right? It will not be continuous in real sense. It will be like this. Then what we do is, because the histogram is a continuous data, in order to make the bars connect to one another, what we do is we change the boundary of these classes. So meaning of that is, here is a difference of 1, 60 to 61, the difference is 1. So when you divide that 1 into two parts, it will be 0.5. So from 55, we subtract 0.5. So it will be 54.5 up to 60.5. In the upper limit, you add 0.5. In the lower limit, you subtract. In the upper limit, you add. So this one, the second one, will be 60.5 up to 65.5. And this one will be 64.5 up to 70.5. So this is how we make it continuous. And this one, the data given here, is already made continuous for you. Okay, the data is already made continuous for you over here. That's why the frequencies are already registered. But in real world, when you work on this is the type of data that we get. And then in order to construct the histogram, we change to continuous like this if they are not continuous. In my example here, the difference was 1. So when I divide 1 into two parts, it is 0.5. So I got decimals. But here the difference was 2. And when you divide that 2 into two parts, it is 1. So you don't see any decimal values over there. Did I answer that question?
Yes, I'm going to think about it some more, but thank you very much.
No problem. Any other question? Okay, if not, we'll go to next example. Okay, here in this example, we are going to look at next way of picturizing the data or visualizing the data, and it is using the frequency polygon. First, we are going to look at the definition of frequency polygon, and we are going to construct the frequency polygon here. So the first definition, frequency polygon is a graph that displays the data using a line that connect the point plotted for frequency at the midpoint of the classes. So you can see here we are graphing, or we are drawing a graph for the midpoint, okay, midpoint of the classes and frequency. Meaning of that is this. So in order to draw the graph, you know that we make the X and Y axis like this. So we'll definitely do that. X axis, Y axis. Along the X axis, what you have is the midpoint of the classes. Okay, along the X axis, you'll have the midpoints. And then along the Y axis, you'll have the frequencies. Along the Y axis, you will have the frequencies. Make sure you label it like that. Then here are the classes. You can see 50 through 60, 60 through 70, 70 through 80, 80 through 90, and so on. We are going to find the midpoint of each. What is the middle point of 50 through 60? Anybody can answer. What is the midpoint of 50 through 60? 55. So you can label that. You can start with 55. That's okay. Then what is the midpoint of 60 through 70?
65.
65. So the next one will be 75, right? Then 85. Then you have 95.
105.
105. Very good. So that's what we'll plot along the x-axis. You can see that along the x-axis, I started at 55. So the gap here from 55 to 65 is 10, 65 to 75 is 10. But here you don't see the uniform gap. So what we try to do is we just make a clink there, just like that. Meaning of that is I squeeze the x-axis over there a little bit. Okay.
I have a question.
Yes.
We're not supposed to finish on x-axis at 115 because the last class is 100 and 110.
What is the middle point of 100 and 110? What is in between 100 and 110?
105.
105, right? So you can go one step ahead. That's totally fine. Yes, you can do that. But the midpoint of this one is 105, right?
Okay, that means you just stay on midpoint.
Okay. So let's see.
Okay.
Along the y-axis, you have the frequency. You can see the frequencies are 5, 12, 10, 8, 3, 2. You can see the maximum frequency is 12. So you want to go up to 12. You can calibrate your y-axis the way you want. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can go by 2. I'm going to go by 2. 2, 4, 6, 8, 10, 12. Is it looking beautiful?
Yeah.
Okay, there we go. Let's plot now. So for the first class, what is the frequency?
5.
5. So for this 55, you have to go and plot 5 because you're drawing the graph between the frequencies and the midpoint. So 55 and then 5. So 55 and 5. Is that the right point?
Yeah.
Okay, 55 and 5. The next one you have is for 65. What is the frequency?
12.
12. For that is 12 all the way up here. Is that right? Can you see that?
Mm-hmm.
Yeah.
Okay. And then for the next one, what is the class? It's the third class, right? Midpoint is 75. Frequency is 10. So we'll go to 10. Is it somewhere there?
Yes.
Looks like
Okay. Yeah. Is it a little good?
Yeah.
Not so much. For 85, it's 8, right?
Yes.
For 85, it is 8. Somewhere there. And then for 95, it is 3. For 95, it's 3. Just above 2. That's 3, right? And then for this one, it is 2. Okay, it is 2 right there. Do you see that?
Mm-hmm.
Now, if I connect these dots, okay, straight line from point to point and draw that curve, this is almost a frequency curve. This is not yet a frequency polygon. When I say polygon, can you tell me the definition of polygon or what is the meaning of polygon? Who wants to tell what is a polygon?
It's a circle with
Polygon is a closed figure, right? It has
close figure. Like
yeah, it has sides. It can be 3 sides, 4 sides, 5 sides, and so on. But it's a closed figure. But you can see here, this is not a closed figure yet. So what you have to do is you have to extend this to the midpoint over here. See, it is assume that there is a 45 somewhere here. If there is a 45 somewhere here, the midpoint will be here, right? So come down to that. We don't have 45 to 55. Do you have that class over here? No, right? That class is not there, so frequency is 0. So if you drop down here like this, you'll come to the x-axis. And you'll do the same thing over here. You drop down to the x-axis, okay, where the frequency is 0. Now, by doing that, see, we created a closed figure. You can count how many sides are here if you want. You don't have to, but in this case, you can count. See, this x-axis itself is one side. This is another side, 2, 3, 4, 5, 6, 7, 8. So we got a polygon with 8 sides. You don't have to name it, but if you know what is the name of polygon with 8 sides? Anybody? Look like I lost connection. Are you guys still there? Can you hear me? Can you hear me?
Yes, now.
Okay, I think I lost connection.
Ah, yes, there you are.
Okay. I am still here, but I lost connection. I'm very sorry about that. I think it's still recording, which is great. Can you see the shared screen now? Can you hear me?